So you can make at least 10 cakes per day. So what y'all said was, oh, one student said y equals greater than or equal to 10. Okay, so why is it greater than or equal to 10? Why is it greater than instead of less than? At least, okay? Cool. All right, let's go ahead and go to slide 2. So let x represent the number of cakes. If x is less than or equal to 15, it means that you can make which one of these? There you go. At most 15 cupcakes per day. Okay. On slide 3, imagine you're a baker just starting out the business. You make two things, donuts and pizzas. That would be a really weird bakery, but let's go with it. Unfortunately, your dough making machine can only make 100 balls of dough per hour. Each donut requires a single ball of dough, but a pizza requires 2 balls of dough. If you make 10 donuts, what is the maximum number of pizzas you can make that hour? Take a moment, try this problem. All right, so how many can you make pizzas can you make in that hour? Go ahead, go ahead. He says 45. Anybody else say 45? Okay. So how many can we make total in an hour? 100, right? Okay. So how did y'all get that? So if we can make 100 in an hour, what? Go ahead. Go ahead. Okay. 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 So he did 100 minus 10. That gave us 90. 90 divided by 2 gave us 45. Right? Good. All right. Slide number 4. You can make at most 70 donuts per hour due to the physical restrictions. If X represents the number of donuts produced per hour, which of the following statements is the best way to express this? At most 70. What does that look like? So at most 70. All right, so we got a couple of people putting X is less than or equal to 70. So how do I know if I should put the equals or not equals underneath? Like the line underneath or not? What from my problem tells me? At most. At most 70. So you could do 70, but that's at most. Does that make sense? Okay. All right, looking at the next slide, you also can make about 40, at most 40 pizzas per hour. Y represents the number of pizzas produced per hour. Write an inequality to represent this. Take a moment. All right, so y'all put Y is greater than or equal to 40. Some of y'all put Y is less than or equal to 40. Remember, at most is going to mean that 40 is the maximum, right? 40 is the bigger number, so it's going to have the alligator mouth facing towards it when we say at most, okay? Oop, nope, it's Y. All right. Looking at the next one. As constraints on donuts and pizzas. By the way, you cannot make a negative number of donuts or pizzas. Using X for the number of donuts produced each hour and Y for the number of pizzas each hour, choose the inequality to represent this constraint. So you cannot have negative donuts or pizzas. Which one does that look like? All right, so I see some people picking x is greater than or equal to 0. Somebody put y is greater than or equal to 0, or y is greater than or equal to x. But remember, these are two separate instances. We're talking about the donuts and we're talking about pizzas. So looking back at our options, we could have 0 pizzas, right? Like we could just be making donuts. So we're going to say x is greater than or equal to 0 because it cannot be negative. Y is greater than or equal to 0 cannot be negative. So you should have picked that first one and that third one. Okay. Go ahead and read over this one and see which one you would select. Okay, so what information did they tell us in this one? What else? What they tell us about pizza versus donuts? How many balls can we make in an hour? 2 for pizzas, right? And pizzas are y. What about the x's? It's just gonna be 1x, right? Now, is it at most 100 or is it more than 100? Only can be 100. So at most 100, right? So which one of these inequalities looks like that? This guy. Okay. Any questions on that? Because you got to be able to create that inequality because the next thing is you're going to graph it. Okay. All right, looking at slide number 8, it says, recall that each hour there are between 0 and 70 donuts and 0 and 40 pizzas produced. Also recall that each donut requires a single ball of dough, but a pizza requires 2. You can make up to 100 balls of dough each hour. Type in the missing inequalities below. So what I want you to do is type in the inequality that corresponds to what's on this left-hand side. Okay, go ahead and take a moment. All right, so looking at the between 0 and 40 pizzas, how do I type that inequality? How do I type between 0 and 40? Well, so what's going to be on my left-hand side? 0. Okay, and then I'm going to put that y in the middle. And then I'm going to put 40 on the other side, right? Now, the dough constraint that they give us, they said it can only be up to 100, right? And it requires 1 for the donut and 2 for the pizza. So we're going to say x plus 2y is less than or equal to 100. Remember, that's the same inequality that we just wrote on the last slide. There we go. All right, once you get those done, you're going to hit shade inequalities. Look at this beautiful picture. Okay, where does our answered choices lie? Like, where are we going to actually pick our answer choices? So what would work? Well, the only place that works is where these all overlap, which is right in here. Okay, so this region right here would be in our answer. So we could pick any point from here and it would work. All right, so looking at the next one, it says shade the region on the graph that satisfies the constraint. So you're taking your pen taking your pen and you're going to shade that region. Go and do that now. Look at my awesome squiggles. All right, so here's some vocabulary. So once you finish shading, this pops up. What is the name given to this portion of the graph that satisfies all the inequalities? Is it zone of possibility, plausible region, feasible region, constraint satisfaction area? These are awesome names. So the words that you're going to see most often are feasible region. Okay, you're going to see that kind of often. All right, go ahead and drag the dots to 3 possible combinations of donuts and pizzas. Try to choose points that nobody else in the class is going to choose. Okay, so go ahead and take a moment, plot those 3 points. I need everybody to do that one. That's on slide 10, because the next slide, we need the data. All right, so the bakery sells every donut or pizza that it makes. The profit made on each donut is $1.20, and the profit made on each pizza is $2. Which of the following rule for $P, the total profit for making X donuts and Y pizzas in an hour? So again, they told us each donut is $1.20. The profit for pizza is $2. How would we write our equation? Okay, so 2 of you are kind of on the right track. Okay. Thinking about this, which one is X, donuts or pizzas? Donuts. Okay, and donuts cost $1.20, right? What about pizzas? Pizzas cost $2, and there are Y value. Okay, so you got to make sure that you pay attention to what do they define X and Y as. Okay, so this should have been 120X plus 2Y, so it should have been that second one. All right, on the next one, it says the 3 options of donuts and pizzas you chose earlier are shown in the graph below. Okay, recall that the profit is $1.20 per donut and $2 per pizza. Fill out the table with the total profit for each option. Okay, so they give us 9 donuts, 60 pizzas. And you just told me that the equation for this is 120X plus $2Y. Take a moment. Those of you who want to go into computer programming and that kind of stuff, this is the kind of stuff that you will need. What companies like to do is they like to say, all right, here's our constraints, here's the equation for this, and then you plug it into the program, and then it runs it for you. So this stuff is called linear programming. And yes, you do use it in computer programming. All right, so the way you would go about doing this is you would take X, which is your donuts. Now your number probably is a little different, but if you plugged in your donut number, which is 13 for me, and then for pizzas, you plugged in 18 because that's the number that they give me right here. All right, and then I go into my calculator and I type 1.20 times 13 plus 2 times 18. They make a 51.6 profit. So I would type in here 51.6. And then I would do it for the next 2. Okay. Looks like majority of y'all got to that point. Okay. So on slide 13, of the 3 combinations we considered so far, what is the maximum amount of profit the bakery can make per hour. So what's the total amount that they can make in an hour? Let's think about that one. All right. So what's the highest profit that you see so far? What's the highest profit you see so far? Somebody said 114. Can anybody beat that? Okay. If I plug in like any of these numbers, I get like 50 to 80 roughly. If I plug in 70, 0, I think I get like 84 or so, something like that. If I plug in 20, 40, I get 104. If I plugged in 70, 15, that gives me 114. Yeah. Do you see where it's crossing all these lines? Like this point right here, that's crossing all these lines, right? That's going to be real important in just a second. So 114 is the maximum amount of money that they can make in an hour. Okay. One nice thing about profit maximizing is that for this type of problem, the best combination will be one of the vertices. Okay, so let's talk about what a vertices is. Back in geometry, it was where two things met. That's what a vertex was. Vertices is just a plural of vertex. So for instance, A is a vertices. Okay, and this point right here is 0, 40. Okay, can you fill in the other places where there's a vertices? Now they have it labeled, so just put in those points. Right, so hopefully this was the easy part. What'd you get for B? 20, 40. All right, what'd you get for C? 70. And what'd you get for D? 0. And then 0, 0, right? Okay, so these are the vertices. These are the corners of the graph, the corners of the shaded region. Okay. Now recall that the profit is $1.20 and pizzas are $2. Calculate the profit for at each corner point and hence work out the best combination of donuts and pizzas that should be made per hour. Enter the optimal number of donuts and pizzas together with the total profit per hour. We've kind of already done this part. But if we plugged in 0, 40 and we plugged in 20, 40, it wouldn't be as large as 70, 15. So 70, 15, and that's going to give us a total profit of $114 per hour. Okay, remember that's using that equation and we're just plugging those numbers in. Yeah. Okay. Slide 16 is what your performance final question will look like. Okay, slide 16 is what your performance final question is going to look like. What they're giving you is a scenario. They give you the inequalities, and then they say, tell me what the constraints mean, graph it, and then I think the next slide has another question on this. Okay, so one of your questions on your performance final is going to look like slide 16 and 17. Okay, take a moment, read this over, and see if you can describe the constraints. Like, what do these actually mean? Where do they come from? And then graph the inequalities. So what you're going to do is open up Desmos, type these all in, and then do a little sketch on here. I know it's kind of hard to sketch that. I'm going to graph it up here just to make sure your graph is correct. Okay, so if I take all my inequalities and I type them in, you're going to get something that looks like this. I personally don't like to put the x is greater than or equal to 0 and y is greater than or equal to 0, but I'm going to do it just to show you. Normally I leave that off because I can't see all of the stuff otherwise. I blame my old eyes. Okay, so looking at this, you should have something like this. You're only looking at the vertices of the really dark shaded region. Okay, so if we get rid of these two, we can see that our vertices is going to be here, here, and here. Okay. The vertices are here, here, and here. So we got 0, 6, 6, 4, and 8, 0. Okay, so going back in here, you can draw that if you want. I know it's kind of hard to do on a Chromebook, so don't have to worry about that one. So again, we're going to record the vertices right here. So what were those? Good talk. Thanks, guys. Thanks, guys. 0, 6, 6, 4, and 8, 0. Okay. All right, so now we're on slide 18. They give us this equation. So this is the next part of that performance final question. Okay, so use the profit function, which is given right there, and the constraints given to determine the maximum profit of the manufacturing both backpacks for the given constraints. Okay, so the coordinates that we're going to use are going to be 6, 0, 6, 4, and 8, 0. Okay, what I want you to do is I want you to find the profit using that equation up here at the top. So you're plugging in these values and tell me what the number would be. All right, so we plug in 0, 6, 6, 4, and 8, 0. So this is what I got when I plugged those in. I got for 0, 6, I got 480. For 8, 0, I got 640. And then for 6, 4, I got 620. So which one is going to be the most? Not 6, 4. Well, look at it. 620 versus 640. Would you rather have $640 or $620? 640, right? Which I plugged in 8, 0 for that one. With me? So I plugged in 8, 0 for that one. So this is going to be 640 here, 620 here, and 480. I plugged in 606 and I got 480, right? I plugged in 64 and I got 620. And then I plugged in 80 and I got 640. You said 64. 64 is not the highest though. Good? Okay. All right. Good morning. Okay. Huh? No, he said 64, the point. 64. 640 is the highest though. You said the point, 64? Mm-hmm. Okay. So we're gonna let's try one more. So on slide 20, they're asking something similar. They're asking for you to define the constraints given this word problem. Okay. I know reading word problems and then doing math kind of is not our favorite. So we need to make sure that we're practicing it because again, that's a question on the performance final. And hopefully it's one that you're going to want to pick. Okay. So go ahead and take a moment, read this over, type your constraints in. Okay. So that's all those inequalities. Okay, take a moment, try that. A factory manufacturer doodads and whirligigs. It costs $2 and takes 3 hours to produce a doodad. It costs it costs $4 and takes 2 hours to produce a whirligig. The factory has $220 and 150 hours this week to produce these products. If each doodad sells for $6 and each whirligig sells for $7, then how many of each product should be manufactured this week in order to maximize profits? Okay, so they told us a lot of information, so let's break it down. All right, we have doodads, which are going to be $2 to make and 3 hours to produce. And they sell for $6. And then they have whirligigs, which are $4 and take 2 hours to produce and sell for $7. Okay. So it kind of gave us like a little too much information, but it's okay. All right, so let's write the inequalities really quick. These are called the constraints. Okay. So the inequalities, can we have a negative doodad? No. Also, before we start there, what is our x going to be? Doodads or whirligigs? Doodads. I'm assuming that's what that was. Oh, okay. And then y is going to be our whirligigs, right? It's just like, no, it's just like, it's like a funny way to say like thingamajig. Like, it's not an actual thing. Yeah. All right, so we can't have negative of those. We're going to say x is greater than or equal to 0. Y is greater than or equal to 0. Okay, now they tell us that it takes 3 hours to produce a doodad. That means that we're going to do 3 times x. And how long does it take to produce a whirligig? It takes 2 hours. And they only have 150 hours to spend, right? So we're going to say up to 150 hours. We wrote a constraint for the hours. Now we're going to talk about the money. So they tell us that it costs $2 to make a doodad. So we're going to say 2x. And then it costs $4 to make a whirligig. We're going to say plus 4y. And they only have up to $220. $220. Now they say down here at the bottom, type your objective function. This is going to talk about like profits. This is talking about how much they're going to sell these for to make something. When they say maximizing profit, that's going to be our objective function because our objective is to make money. Does that make sense? Okay. So when we type our objective function, we're going to look at the cost, or I'm sorry, how much they sell for. So it sells for $6. So we're going to say 6x plus 7y. And we're trying to figure out how much money we're going to make. So we're going to say equals P. Now we're going to take all of these and we're going to graph it. Should have known. All right, so we're going to take these and we're going to graph them. So we go into Desmos. And we got 3x plus 2y is less than or equal to 150. On the next one, we have 2x plus 4y less than or equal to 220. And then we got x is greater than or equal to 0. And then y is greater than or equal to 0. Okay, so looking at these, I took my inequalities and I graphed them. We're looking for the shaded region, right? Okay, again, maybe a good idea to get rid of these two so that you can actually see what's going on. Okay, and we need where they're overlaying each other. So like right here, they're overlaying. Right here, they're overlaying. And right here, they're overlaying. So those are our 3 vertices, right? Well, really, we have 4 because 0, 0 is always 1. But we don't need to plug that in. Okay, and we're trying to again. Okay. So now what we're going to do is take these 3 points and I'm going to plug it into my constraint, my objective function. So 6x plus 7y. So we're going to plug these into our 6x plus 7y and see which one maximizes our profit. So I'm going to take 0, 55. $50, 0. And that last one was 20, 45. I'm going to plug them into this equation really quick. What? So proud of you. Look at you. Be like that sometimes. Okay, so which one produced the most? $20 and $45, right? Okay, so 20 and 45 will give us $435, right? So this is in each week. You get paid bi-weekly. 2 weeks. There you go. All right, so we would make $435 as our maximum. This is name that function. So we've learned a lot of different types of functions this semester and last semester. So the first one we got right here. Okay, looking at this, we have a parent function, which is the square root of x. What type of function is that going to be? What is the name of that? Is it linear? Is it quadratic? Is it cubic? Is it a square root, or also known as a radical? Is it exponential, or is it a log? So out of those, what is this? What's this symbol? Square root. Okay, so up here you're going to say square root is the name. Now, what does it look like? Well, if we go into Desmos and we just type square root of x, square root of x, look at the graph that I get. It looks like this. So looking at our options, we would have B be the graph. I can't pull this over to move. That's cool. Okay, so you're going to take B and you're going to sketch it down here at the bottom. What about this next one? They only give us the graph, but it's a straight line. What kind of function is that? What's the name of that guy? So down here at the bottom, it has a straight line. Which one of those looks like a straight line? What's the name of it? Linear. Okay. The parent function for linear is going to look like C. So we're going to say f of x is equal to x. The next one, they give us the parent function. What are these little bars around an x? What are these bars? What is it? Absolute value. Okay, so we got absolute value. And that's always going to look like a V. Okay, so when we sketch the graph, it's going to look like this. Okay, so we got rid of A, B, and C. Okay, let's do something that we remember back from Algebra 1. This U shape, what kind of function is this? It's not linear, it's not a square root. Not a log, not exponential. What do we got? So this U shape is going to be called a parabola, which is going to be a quadratic. So we're going to say quadratic. And that's going to have that exponent of x squared. Now, the only two options that we have left are right here, we have this x to the third. Well, this guy's missing a graph, so D is going to go right here. Kind of go by process of elimination. And this is called a cubic function. And the one that's left is a cube root. So cube root function. Okay, so on the next slide, it says, given the following inequalities, graph them and determine two possible solutions. So all we're going to do is take these two inequalities. So we got x squared minus 1. And then we've got x plus 1. So I'm going to take these and type them into Desmos. Good morning. Oh, okay. Never mind. Okay, what are two possible solutions for this? What are two possible solutions for this? Remember, it only can be in the dark shaded region where both colors overlap. Possible solutions. Two possible ones. So 0, 1 does work. And then 1, 1 would work. 1, 2 would work. Okay. Do you see where I'm getting these from though? It's only in this shaded region. You could have a negative because we're not dealing with a real world problem. So like 0, 0 would work. Okay, so all of these would work. Negative 1, 0 would work. Good. All right, so you can write all 4 of these down on your paper. You're writing these down. Take this one and we're going to plug it in. Okay, instead of putting g of x into Desmos, I think you can type g of x into Desmos and it's okay. I think so. We'll try it. We're going to say again. Yeah. Okay, put it as y. All right, so we're going to type this junk into Desmos really quick, and then we're going to find two possible solutions. Crazy. I know. Notice how there is no line underneath. Oh, that is not even close. Good try. No, because it creates a slider. Oh. Okay. So if I have something that looks like this, I want to find two possible solutions. So that means that it's where it overlaps. I need you to be careful on this one. If it is a dotted line, you cannot pick a solution on that dotted line. Okay, so if it's this dashed line right here, can't be any of this. So pick a point that they both overlap. Oh, I'm sorry. So you can pick any point in this region that both colors are overlapping. So like you remember back in elementary school where you combine red and blue? What color does it make? Purple, right? So when we overlap those two colors, we get this purple region. So you could pick any points in these purple regions. So this could be like N1. It could be, it just can't touch the dotted line. N1, so this point right here, that would work. It can't touch the dashed line. Okay. 5-1 would work. Okay. -10, -1 would work. Okay. With me? Then we can talk worldly stuff. All right. So what type of function is this first one? What are these bars called? Absolute value. This one's a little trickier. What kind of function is this guy? It's going to be a straight line when we graph it. So what is that called? Linear. Okay. So now we're going to actually plot these two. Y is greater than the absolute value of x plus 5. And then the other one is going to be y is less than or equal to 2. Ta-da! Okay, now remember, the solution is where they overlap. Okay, so it would only be in here. So like a point would be like -5, 2, or -5, 1, -4. No, so -4, 2 would not be on this because it's on that dash line. You see it? Okay. So -4, 2 would not be a solution. It's anything that's inside this region, but -5, 2 would be. With me? Solid line, you include that answer. Dash line, you do not. Okay, so any point that's inside here. Okay. Questions, comments, concerns? Okay, draw the sketch of this graph, use the little dash line, and then shade that region.